Alright, so in this video, we're going to be talking about how to find the distance from a point to a plane. Now when we talk about that, we mean the shortest distance, okay? We're just talking about the shortest distance from a point to a plane, okay? So, say that your point, we're going to say that that's x1, y1, z1, okay? And your plane is going to be modeled by the linear equation for a plane, which is ax plus by plus zz equals plus d equals 0, okay? The first thing that you're going to do is just pick a point that's in the plane, okay? And that point is going to be x naught, y naught, z naught. Okay, here I have drawn a picture of basically what you just set up, okay? Don't worry about this vector yet. We have a point in the plane, that's the point that you picked, x naught, y naught, z naught. You have your point that you're trying to find the distance with, okay? That's x1, y1, z1. Okay, and of course you have your plane drawn out here, and well, here's the idea. This is your point that you picked. This is how much you missed by. This is the point that's directly under, okay? It's directly under the point that you're working with now, okay? You can kind of think of it like just being on a basketball court, okay? Your coach told you to stand right under the basket, okay? So you're standing, like, let's say the point is the basket, okay? And you need to stand right under it, okay? And that's this point right here. But you either are a little bit tipsy or you're uncoordinated and you ended up over at half court, okay? And that's x naught, y naught, z naught, all right? And you need to figure out, well, when I'm standing under the basket, how far is it going to be to reach the basket, okay? And, well, you can actually be able to do that still because of this vector b, okay? This vector b is literally just going to be the vector from, of course, x naught, y naught, z naught to x1, y1, z1, okay? And that's this vector right here, x1 minus x naught, comma, y1 minus y naught, comma, z1 minus z naught, all right? And what you also know, okay, is this plane has a normal vector, okay? And this normal vector is going to stick up like this. That's your normal vector. So, if you wanted to find, let me get a different color here. If you want to find this distance right here, how did we find that before? Well, before, when we talked about scalar projections and vector projections, that can apply here because this distance is the scalar projection of b onto your normal vector n. Okay, and if that's confusing to you, definitely just go ahead and kind of re-watch that video and get a better understanding of vector projections and scalar projections, because that's exactly what we're doing here. Okay, the distance is going to equal the scalar projection, so we write that as the component of b onto n, okay? And, well, what is the component of b onto n? How you write that is, where do we have it here? That is going to be n dot b, okay, over the magnitude of n, okay? But before this is all said and done, okay, we need to take the absolute value of your component, okay? Because we don't want there to be any chance that our distance will be negative, and the component can sometimes be negative, all right? So don't even take a risk there and just use the absolute value, okay? Because distance is not going to be negative. So right there, okay, so first off, these top bars mean absolute value, and these bottom two bars are going to mean magnitude. Okay, why? Because this is a vector and this is a scalar. Okay, these are two vectors, but when we take the dot product, that's a scalar, so these bars end up meaning absolute value. Okay, so there you go. There's your kind of your starting distance equation. Now, if you're not the best at memorization, this may be where you want to leave your distance equation. And just remember that it's the dot product of vector n and vector b, and you put that over the magnitude of vector n, okay? And you can do that, all right? You can kind of remember it like this, But you can also, if you're a little better with memorization, you like to memorize things a little bit more, if we keep going with our distance equation, we'll get something a little more drawn out where you don't have to find the dot product at all. You can kind of just plug a bunch of numbers in, okay? But it is a longer formula. So first off, what we have to do is start computing the dot product. We have that vector n is ABC, and we're going to dot that with B1, vector B, which is x1 minus x naught, comma y1 minus y naught, comma z1 minus z naught. All right, and that is going to be over vector n, which is ABC, and we have to find the magnitude of it. Okay, so we get our distance is equal to, we have now the absolute value of A times x1 minus x naught plus a B times y1 minus y naught plus C times z1 minus z naught. Okay, and that's going to be over the magnitude of our vector ABC, which is just going to be the square root of the sum of the squares, which is going to be a squared plus b squared plus c squared. And right there, you get your more drawn out distance equation that if you'd like to, you like memorization a little bit more, that's going to be perfect for you, okay? Because, well, now you can just plug in points, okay? You can plug in points and you don't have to worry about finding the dot product or finding the magnitude. Okay, because you literally can just plug in and then go from there, and it's all algebra. Okay, so it's kind of up to you whether you want to do this one or this one. All right, we'll be doing in the next video. We'll be doing one with this distance equation, and we'll kind of just do it out like that. Okay, we'll kind of start from the beginning and work our way to this, and then find the distance. And then in the video after that, our part 2 video, we're going to be just plugging in for this distance equation right here. And so you'll see both methods, okay? Anyways, that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors and the geometry of space in the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.